Ladies and gentlemen, welcome to our keynote on hybrid design for lightweight and high-performance application. My name is Kai Maschalkowski and I'm Innovation Lead Advanced Manufacturing Technologies at Schaeffler. And let me introduce Guy Warren, Director Business Development at Polymertal. Together, we will discuss the role of hybrid materials design and its potentials in lightweight applications for automotive. So first, we will have a brief introduction and we will go through the motivation and the drivers and look at some examples for the application in automotive. Then Guy will give some thoughts about why hybrid design and hybrid materials found their way from aerospace into the spectrum of automotive applications. And together, we will give some insights on the joint approach of Schaeffler and Polymertal for the application of hybrid materials in series production, which will be concluded by a summary and outlook. Let me take the chance to make a first statement here. Some people claim that lightweight design doesn't have much impact on mobility anyway, and specifically on e-mobility solutions. We at Schaeffler claim that lightweight design is a key element for pioneering motion in general, and it will play a major role in finding new ways of mobility for the future. But before we dive into the topic, let me briefly introduce us as a company. Schaeffler started more than 70 years ago with the invention of the cage-guided needle roller bearing in automotive. Today, we are an integrated system supplier for automotive and industry, with over 10,000 products and first-class manufacturing processes for manufacturing of components like bearings and systems for motors, gears, chassis, as well as hybrid and electrical powertrain. In 2020, we filed 1,900 patents, proving our strong basis for innovation. We have an international base of 12,000 customers in the sectors of automotive technologies, automotive aftermarket, and industrial. With more than 200 locations in 50 countries, our 84,000 employees strive for the best solutions with the highest quality for our customers worldwide. Until now, steel is the most important material, of which we process 1.1 million tons each year for the manufacturing of our products. Let us explain in the following how we will make use of the potential of hybrid design for strengthening our product innovation and at the same time reducing the ecological footprint. Today, the development in automotive mobility is dominated by the legislation and the social discourse on climate and environmental protection. Historically driven by raising safety and comfort, the average weight of passenger cars grew continuously. What we see here in the example of the VW Golf from generation 1 to 7. The challenge of this ongoing weight spiral was and is one of the major motivations for lightweight design. And additionally, the need for fuel consumption and resource efficiency has put a special emphasis on the topic. OEM fleet-wide targets are bound to CO2 reductions down to 59 grams per kilometer starting from 2030 on. In other words, more than 35% savings from the current limit value are required. Furthermore, CO2 footprint is only one aspect in the ecological equation. If we want to look at the impact of industrial products on the environment, we have to take the complete life cycle assessment into account. LCI is guiding us the way to a sustainable, renewable, and circular product development. In this regard, lightweight design becomes a modern, new way of thinking as a prerequisite for qualifying in this race. and even more specific for mass production. Intelligent ways of sustainable, multifunctional and multi-design becomes indispensable. And even more specific for mass production. Intelligent ways for sustainable, multifunctional and multi-material design becomes indispensable. To this extent, we are facing a huge energy and resource challenge, and lightweight design will be a part of the solution. But what is it? For us, lightweight design is on the one hand an intelligent way in engineering for efficiency, which means making more out of less. On the other hand, it is an enabler for breakthrough technologies, specifically if we look at the power-to-weight ratio, which we know from aerospace and aircraft design. But moreover, it will contribute to new mobility concepts for a sustainable future. Here we firstly have to care for primary effects which go down to sourcing and consumption of resources needed for production. This might be addressed by increasing the material efficiency, and as an example for this is the substitution of steel. And secondly, we have to care for secondary effects which are related to the consumption during operation of the vehicle. As an example, we can look at an EV with a fixed battery performance and capacity. If we are able to reduce the mass of the vehicle, the performance according to dynamics as well as energy efficiency will go up. That is why VW stated, for example, that they rather invest in cost-efficient lightweight design than inexpensive batteries, meaning they can spare battery weight and cost by an intelligent vehicle design approach. So let us take a look what we can learn from aerospace.
Thank you, Kai, for all the information about the lightweight design approach of Schaeffler. I will take it from here, and Polymertal is proud to be a partner of Schaeffler within trying to leverage the lightweight design in automotive applications. We see it as something that we would like to achieve in better efficiency. So let's take a look back at composite materials that were coming from the aerospace. Specifically, we all know the 787 by Boeing. This aircraft is made up of 50% composite materials. So these are advanced materials that have been reducing the weight of the aircraft by 20%. Now, the lower weight of the aircraft is enabling less lift force and thrust during flights. This means that if the 787 has 50% composite materials, which means that 20% weight savings, that was able to improve the fuel efficiency by 10 to 12%. Improved fuel efficiency means less fuel consumption in every flight. This results in improved carbon footprint. If we take a look at the global automotive sector, the composite market size is valued at $21 billion in 2019 and is expected to grow at a compound annual growth rate of 7.5% per year from 2020 to 2027. So this is a trend that is growing in high numbers. So let's see what we can do with it. Let's see if we can take lightweight materials that are applied in aerospace and put them to use in automotive. The results can be amazing. But let's look at another very important trend that is growing today, and that is additive manufacturing. So in aerospace, we can see that the market is already growing towards the mainstream of using additive manufacturing. For example, in interior cabin components, as well as fabrication tools and replacement of old aircraft components. Those once hard to get old aircraft components can now be supplied from the CAD to the aircraft in days. And that is a real big change in the industry. We see that the automotive sector is also slowly adjusting to this trend and entering early mainstream of additive manufacturing. This enables low series production of parts for these vehicles, as well as prototypes and fabrication tools. Additive manufacturing allows to unleash creativity and removes constraints from engineers. In the past, if you were a development engineer and you had to go and get a part that's being injection molded, what you would do, you would actually have to go and produce a mold that would take you between 3 to 4 months to get the first parts after T1 injection. And that is after you design the part, design the mold, you did all the process, and now you have to get the parts for the first time. You see them after about 4 months. Now, when you get the parts and you integrate them into the system, there could have been some mistake, some error, miscalculation that caused you to have an imperfect system. And at that stage, you're already far behind in the project. So you want to leverage that. You want to become better. So what do? You can move to additive manufacturing. The additive manufacturing allows you to have parts from the development to your facility within a few days. And that is a big change for development sequences and engineers that can bring parts for first integrations very early on in the development stage. Polymertal's core know-how is to take tailor-made solutions from development to production of these hybrid materials that are made from polymeric substrate and a metallic cover. The technology is called electroless metal plating, and it consists of a chemical surface preparation to accommodate for the metallic layers to come. The preparation enables a strong bond between the polymer and the metal layer. After the first metallic layer, we add a final layer that can be a form of nickel, silver, tin, or gold. This creates a protective layer of the polymer that enhances its capabilities significantly. The part that is now metallized can be electrically conductive and is used, for example, in EMI shielding applications. It is also wear and corrosion resistance and can be used in fluid systems when we know that nickel is against corrosion and wear. If we use additive manufacturing, it enables complex design and provides design freedom to the engineer. In addition, it is now much stronger in tensile and impact resistance and can be used in more rigid systems. And finally, it is fully recyclable, meaning that we can separate between the metallic cover and the polymeric substrate, and each and every one of them can be recycled on its own. In addition to that, the entire process is low energy consumption process. It's chemical baths, and there is not a lot of energy involved in making it. We don't use any high temperatures. And lastly, it is more socially sustainable than metals. So metals we know today are mined in less fortunate countries, and human rights are violated during this process. So we're able to bring down the carbon footprint and as well to be more socially sustainable. So now that we all know the automotive trends, let's see how Polymertal solutions are able to enable these trends in automotive solutions. And this is through a hybrid part solution. So for example, lightweight design of hybrid materials can be an alternative to metals. Who would not want to change his metallic part to a hybrid part, which is lighter, more durable, and can be used in many different applications in highly functional areas of the vehicle. It's also very fast-track development through the additive manufacturing, so you're able to get parts within days, as well as being more sustainable and reducing weight through the replacement of metals, as well as fuel savings and reduced emissions. For example, we can see in the graph that the CO2 emissions in automotive applications have to go down from 140 grams per kilometer to 75 grams by 2025. And this is the difference between what we had in 2010 and 2025. So that's quite a long period, but it's significantly changing because we have to be reducing the carbon footprint by almost 50%. And why is this trend coming? Because there are going to be more fines per vehicle in a fleet from 0 in 2010 to about 12,000 euros per vehicle in 2025. So if traditionally in the past we would be using steel or aluminum, which is maybe a bit more modern, we're still being at a very high rate of weight. Now, the carbon fibers that were introduced into the automotive were able to reduce the weight by about 50%. And carbon fibers are part of this composite world. So they're able to reduce the weight, but not the price. So the price remained high with carbon fiber alternatives. Now, what Polymertal was able to achieve is to reduce the weight to the level of carbon fibers, but also keep the prices that we were used to having in injection molding while only adding a fraction of the price to accommodate for the metallic layer, which is still significant because you can still use these parts to be functional parts within structures or highly functional areas of the vehicle and maintain them over a lifetime, which is something that polymers or composites were not able to do, not on the functional part or on the price part. Polymertal was able to figure this out and reduce the weight versus metals by about 50% to the level of the carbon fibers, while still maintaining the price level of the injection molding parts, while only adding a fraction of the price to accommodate for the metallic layer. This enables us to use these parts in highly functional areas where there is a need for these types of parts to be used over a lifetime, and they are able to maintain it for a very long period of the vehicle. So we see that Polymertal is as light as carbon fibers, but is more sustainable and more cost effective. Back to you, Kai.
Thank you, Guy, for the insights. Now, in automotive, lightweight design has to be cheap and robust. What we need to achieve this is an holistic view in engineering on lightweight solutions. The first step is done when we start designing our components and evolving them into highly integrated systems like our current e-axle drives or our dedicated hybrid transmission. Consequently, design and material together bear a high potential to achieve all three targets aspects of cost, CO2, and weight reduction. In this example of a water pump housing, a 70% reduction in CO2 footprint was achieved by switching from aluminum to polymer. An example for multi-material design is our current approach for a shift fork, where we combine metal parts and polymers to a multi-material approach. This definitely bears challenges like anisotropic material properties, and it engages disciplines like multi-material topology optimization, multi-scale and multi-physics simulation, load data management, and more. A consequent continuation of multi-material design is the application of hybrid materials. Together with Polymertal, we partner on a proof of concept for a needle bearing cage in a gearbox application. Requirements for a series application trend to a needle RPM over 100,000 and accelerations of 6,000 G. Due to the expected increase in part diversity in e-mobility, 3D printing becomes a center of gravity for cheaper, faster, and more sustainable manufacturing in regard of lower quantities and innovative design solutions. Our goal in this application here is to increase the media and the temperature resistance of the polymer cage, which will be applied at an operation temperature of 140 degrees. This objective shall be reached by metallization of the polymer. Further optimization potential lies in the mechanical strength and in the stiffness to be enhanced, as well as the improvement of the friction properties by a doped surface. As future scope, we are looking forward to transfer the achievable weight performance value proposition to other applications like we see here. This comprises ECU housings, including EMC shielding, gearbox housings, bearings, gears, and e-motors as well. So let me conclude on this. Increasing resource and energy efficiency is a major challenge of automotive mobility today and in the future, and lightweight design can be a part of the solution. Materials applied play an important role as success factors. Conventional metals like steels and aluminum are substituted by sustainable materials, and together with product design for recycling, along with green production systems and clean technology, neutral footprints can be achieved, thus contributing to the vision of a circular economy with zero waste. By putting all important pieces together, sustainable ways of mobility are at hand, And enabled by an intelligent approach of a fully integrated transport ecosystem, we help paving a lighter way into a better future. Let's get ready for takeoff!